Hi students, we'll be discussing J advanced previous questions and this is J advanced 2023 paper 1 we'll be discussing it over here today. When we look at overall questions, some of the questions are very simple but almost around 60 to 70% are moderate or above average. So we'll be discussing these questions one by one, okay? Now let us go to the first question. See, when you go through a question, you have to read the question well, understand the question well, and then only proceed to the answer, okay? So let S is equal to 0, 1, open interval 0, 1 union, open interval 1, 2 union, open interval 3, 4. And T is equal to set 0, 1, 2, 3. Then, which of the following statements are true? Option A, there are infinitely many functions from S to T. There are infinitely many strictly increasing functions. Then, the number of continuous functions from S to T is at most 120. Every continuous function from S to T is differentiable. So this is the question. Now see, when you look at the domain, this is the domain of the function. Defined domain is, it's a union of 3 open intervals. 0, 1 union, 1, 2 union, 3, 4. And T is the set. This is the codomain. That is, codomain is set 0, 1, 2, 3. This is a finite set. This is a discrete set. And moreover, this is a finite set. And this is, this is an infinite set. Infinite set. This is infinite set. Because interval, 0, 1 interval is infinite. 0 to 1, there are infinitely many points in between 0 and 1. There are infinitely many real numbers between 0 and 1. Similarly, so 1, 2, open interval 1, 2, open interval 3, 4. So, suppose I draw this interval, suppose like this. See, we take open interval 0, 1, open interval 0, 1. Then open interval 1, 2. Then the next open interval is 3, 4. Okay, 3, 4. So this is 3, 4. So we have to consider this open interval, this open interval, and this open interval. Or rather, I would try to draw it in terms of arrow diagram. Arrow diagram also like this. Suppose I take this 0, 1 over here, 0, 1, then 1, 2, then 3, 4. Say 0, 1, this is an open interval, contains infinitely many points. So this is S and this is T. And this is an infinite set. This is 0, 1, 2, 3. It's a finite set. Now what is the question? The question is, first one is, there are infinitely many functions from S to T. Is it true? There are infinitely many functions. See, between 0, 1, there are 0.1, say for example, 0.2, 0.3, etc. We can find out infinitely many points in between 0 and 1. So each element can be, for example, 0, 1, 0.1, 0.2, etc. It can be mapped to 0, 1, 2, 3 in infinitely many ways. Infinitely many ways, okay? We can map it from infinitely many ways. Why? Because it contains infinitely many points. And the right side is what? Right side set is, or the codomain is finite. The domain is what? Infinite set. So obviously, there are infinitely many functions we can define from S to T. There are infinitely many functions we can define from S to T. So option A is true. This option A is true. Because we can, in different ways will be there. Different ways we can map from S to T. Okay. So obviously option A is true. Now, look at the next option, option B. there are infinitely many strictly increasing. This word strictly increasing is very important. Strictly is important. Strictly increasing functions from strictly increasing function means what? Suppose I draw this a function like this. This is a strictly increasing function. I'm just drawing it for an example. It's a strictly increasing function. See, for a strictly increasing function means what? For x1 greater than x2, f of x1 greater than f of x2. That means for different values of x, there will be different images, and moreover, when x increases, the y value also should increase. But unfortunately, what happens? We are given only 3 points, 0, 1, 2 and 3. Only 3 points are given as the elements on the right side, set T or the codomain. Codomain contains only 0, 1, 2, 3. So when x increases, suppose I take, for example, 0.1 image. 0.1 image is suppose 0. Then 0.2, if suppose 0.1 image is 0, then 0.2 image should not be 0. It should be greater than 0. For example, 1. And suppose I take 0.3. 0.3 image, suppose it is say 2. Suppose I take 0.4. 0.4 image is 3. Now it is finished. Why? Because x1 greater than x2 implies f of x1 should be greater than f of x2. So what happens? We are finished with, or the number of elements or number of mappings are over. We can only map these 4 elements. So remaining elements we cannot find image. Why? Because it is strictly increasing. Strictly increasing means what? When x1 greater than x2, f of x1 should be greater than f of x2. So we cannot form a strictly increasing function in this case. Had it been increasing, just increasing, suppose the word strictly is not there, then you see, for example, I can draw a function like this. Say, for example, suppose this element, this image is, say, for example, 0, this image is 0.1, say 0.2 image is suppose 1, 0.3 image is again 1. So it will be like this only. We can map in this way only. So it is not increasing actually. It is only horizontal. Understood? So we cannot form strictly increasing function. There are infinitely many strictly increasing function from S to T is wrong. Okay, so we cannot do that. Now look at the next question. See, the number of continuous functions. Number of continuous, this word is very important. Number of continuous functions from S to T is at most 1. Before going to that question, I would like to go to the 4th option, option D, and then after that we'll come back to option C. See, every continuous function from S to T is differentiable. What do you mean by continuous function and differentiable function? See, in this case, say 0, 1 image. Suppose I am taking 0, 1. Suppose I take, say for example, 0, 1. An interval 0, 1 I am taking. I am considering interval 0, 1. So, continuous means what? Suppose I take an element, say alpha, in between 0 and 1. Then the immediate neighborhood of alpha, or the left hand limit of alpha and right hand limit of alpha should be equal to the value of alpha. Suppose the image of alpha is say 1. Image of alpha is 1. So this is the image of alpha. Suppose I'm taking the image of alpha is 1. Then what does it mean? For it to be continuous, the immediate neighborhood of alpha should also be 1. Means if you consider the left limit and right limit, that is what immediate neighborhood. The immediate neighborhood of alpha should be, for every point in the neighborhood of alpha should be 1. It will be like this. Suppose I consider another point, say beta, in the neighborhood of alpha. Suppose I take another point beta in the neighborhood of alpha. Then the image of beta also should be 1. the image of beta also should be 1. Why? Because the left hand limit and right hand should be equal. Because the immediate neighborhood of alpha contains beta. Understood? Therefore, the image of beta also should be 1. Now, etc. proceeding. Suppose I consider the neighborhood of beta. Then every point in the neighborhood of beta also will be what? 1. So if we proceed like this, we continue like this, every element in the interval from 0 to 1, in the open interval 0 to 1, will have the same image. That means it will be a horizontal line. Suppose in this case, suppose I take 1, 2. Every element in the image of every point in the interval 1, 2 is, suppose it is 2, then it will be like this. It will be a horizontal line. And moreover, see, this 1 is not included, 2 is not included. Why? Because it's open interval. So if the endpoints are excluded, we don't have to look at the continuity of the endpoints. Where the function is open, where the domain is open, if the interval is open, we don't have to look at the left limit and right limit of the open point, that endpoint. So we don't have to look at the open, look at the limits at 0 and 1. In between 0 and 1 only need to look. So in between 0 and 1, every point, if you look, the image will be like this for it to be continuous. Suppose, for example, I take, say, for example, 0.5, 0 and 1. Suppose I take 0.5, this is 0 and this is 1. Suppose this much interval is this. This is, suppose 1 is the image. 1 is the image. And 0.5 image is, suppose it is 2. Then it will be like this. So what happened? It is broken. That line is broken. If the line is broken, it is not continuous. But over here, we don't have to look at the continuity. Why? Because this is not there in our domain. So we have to consider this as a continuous line only. This is continuous line only, and this is not a jump. This is not to be considered as a jump. Why? Because 1 is not there, 2 is not there. So we can consider it as a continuous line. And suppose 3 to 4, the image is again like this. 3 to 4, the image is like this. So we have to consider it as a continuous line only. It is not a break of the line. The line is not broken. Why? Because we don't have to consider the open points. We don't have to consider the endpoints because it is open interval. So in that way, this function is continuous. And every continuous function, see, this continuous function, so this is a straight line. Straight line is always differentiable. Moreover, it's a horizontal straight line. Every horizontal straight line is differentiable. What is its derivative? That is equal to 0 only. Since it is open interval, it is continuous. And that is differentiable. So option D is correct. Why? Because every continuous function from S to T is differentiable. And now we can come to the third one, option C. The number of continuous functions from S to T is at most. See, continuous function means, I told you, say, for suppose 0, 1, the first interval I1, second interval I2, third interval I3. Okay. This can be mapped in how many ways? Each can be mapped in 4 ways. I1 can be mapped to 0 or 1 or 2 or 3. That means I1 has got 4 ways. Similarly, I2 has got 0, 1, 2 or 3. So I2 also has got 4 ways. I3 also has got 4 ways. So 4 into 4 into 4, 64. The number of functions is maximum 64. It can be maximum in the sense it is equal to 64. This is less than 120. Because it is given like that only. It is less than, the maximum is 120, at most 120. 64 is, obviously it is less than 120. I don't know why this J has given that 120 as the number of functions. I don't know. Anyway, forget about that. So the number of functions from S to T is at most 120 is correct only because it is 64. 64 is less than, obviously it is less than 120. So we can, for the point of sake, we can say to be correct. Okay. So this is a very simple question only, but only thing is that you have to have the full concrete idea of continuity, differentiability, open interval continuity, how you consider the open interval continuity. Because when you consider an open interval, you don't have to look at the endpoints. Okay, and number of functions formula, how to find the number of functions from as s to t, etc. Okay, so that's what. So it's I would like to rate it to be a moderate level question. It's not very easy, but at the same time, it's not very difficult also. Okay.